Hello and welcome back. Today we're within the infrastructure section within Boson NetSim, and today we're going to be planning and configuring multi-area OSPF number 2. Now we've taken a little break. I've been taking a break on the channel now for about a week, I believe, a couple of days. I know I was really getting after it and studying a lot in this book. I've already read it cover to cover once, and then the second time I took notes on it, so I wanted to make sure that I was thorough in reading through it and taking notes. And now I'm reading through it for a third time. But we're going to, I just wanted to take a break and read through it the second time and take good notes. So that was taking up a lot of my time. Instead of me doing labs, I was just reading. So now we're back on the labs. I'm excited to be back. And today we're within OSPF. So that's always a fun protocol to mess with. So it says, we're going to start down here. It says plan, implement, and verify open shortest path first, OSPF operation over LAN interfaces, frame relay using point-to-point network types and layer 3 switches. You will also verify and configure OSPF operation for multi areas and explore alternative OSPF configuration mechanisms. So this is our topology that we have. We have our area 0. So this is our backbone area. It's connected into a cloud, and these look like our frame relay point-to-point connections. Within these routers, it look like BBR1, Core Router 1, Core Router 2, Core Router 3, Core Router 4, and Core Router 5. And then they have their own areas connected out. So you have Area 2, Area 1, Area 3, and Area 4 right here. As we know, OSPF is an interior gateway protocol. So it would be ran within an autonomous system. It's basically to share the routes within the autonomous system, so all the routers and devices can communicate with other devices within the same business. So it basically just shares different routes with all of the routers, so all of the routers know how to get to another router, for example. What else do I want to say about OSPF? All of the routes will share the same LSDB, so they all have the same topology and map of the whole network. So they will use the Dijkstra algorithm to find the shortest path to a certain destination and then forward the packet as need be. So this is a layer 3 protocol, basically to share routes between routers and just communicate information between routers so hosts can communicate with different hosts within the same autonomous system. So yeah, I've already read through all of the commands and also the descriptions for this lab. I have my iPad right here because with OSPF, we're probably going to have to do some subnetting, and I'm going to be doing that on the iPad as we go. So I've already read through, like I said, all of the commands and the descriptions. Look through all of the IP address information in the subnet mask that are relevant. We have all of our PCs, IP addresses, their subnet mask and default gateway. So let's go ahead and get into this lab. We're going to keep our topology up here in the top left as we usually do. We're going to be reading all of our commands in the top right. We're going to be doing our configuration down here at the bottom when the time comes. So let's go ahead and get into this lab task. It says task number 1, plan for multi-area OSPF. So it says this task involves planning the OSPF configuration. You will use the configuration you list here to implement OSPF in task 2. Okay. So it says each serial 00 sub interface on BBR1 and each serial 00 interface on Core R1, Core R2, Core R3, and Core R4 should be configured as members of the backbone. Your configuration needs to be specific enough so that as additional networks are added to the router, those networks are not automatically advertised. The IP routing table on each router should be populated with the specific IP subnets in your network. Using the IP addresses table, list the specific networks and subnet masks using classes in the domain, routing, CIDR notation that should be configured so that only the specific interfaces run OSPF. So it basically, at the beginning of this, it listed all of the sub interfaces and interfaces that need to be configured for the backbone area, which is area 0. So let's go ahead and start out on BBR1. We can either go here and do the enable, and we can do a show IP interface. So I don't believe it's going to give within the output on Boson. It's not going to give us the sub interface IP address information. Let's do an show IP interface brief. See if we can get any output. Be good if I can spell. Yeah. So we're able to see the sub interfaces with the brief command, but not the regular interface command. So we see that we have 12.0.0.1, 12.0.0.5, and 12.0.0.9. They're all going to be in different VLANs. We can see the sub interfaces that specify that. So this will probably be VLAN 10, 20, and 30. But let's go ahead and I'm going to scroll up a little bit, and we can also see the IP address information right here as well. So let's go ahead and subnet some of this stuff out. So let me go down to the question on this side of the screen. So let's start out on BBR1. So let's get an iPad. Let's go BBR1. Okay, so we know that we're going to be doing the 12.0.0.0, and we can see that right here. That's the first serial 00 interface. And for our mask, we're going to do a 0.0.0.3 for area 0, because we're doing the backbone area, and we did 0.0.0.3 because that will be the wildcard mask for a subnet mask, which has a 255.255.255.252. That's how we get that 3, because we do 255 minus 252, and that leaves us with 3. So that's how we got that. Let's go ahead and continue the subnet. We can do 12.0.0.4. That'd be the network address for the serial 00.201. So we do 0.0.0.3 for area 0, and we're going to do 12.0.0.8, and that'll be 0.0.0.3 area 0. So, and then do we do the 04? Let me make sure. It says each serial 0 sub interface. Yep, so we do the 04 as well. So that'll be 12.0.0.12, 0.0.0.3 area 0. So that's it for BBR1. It says we have Core R1, Core R2, and Core R4 should be configured as members of the backbone. So we can start out with the Core R1 router. So let's do Core R1. It's going to be 12.0.0.0, and it's going to have a 0.0.0.3 area 0 as well. Let's go ahead and move on to Core R2. It should have, as you can see right here, it's going to be a 12.0.0.4 for area. Let's do the mask first. It'll be 0.0.0.3 for area 0. Let's go ahead and move on to Core R3. Core R3 is going to be the next subnet. So it's going to be a 12.0.0.8, and it's going to be 0.0.0.3 for area 0. And lastly, let's go Core Router 4. This should be the last router for the backbone area. So we have 12.0.0.12, 0.0.0.3 area 0. All right. So we have all of our area 0 networks that should be in the backbone area. So that is perfect. Let's go ahead and scroll down to question number 2. It says the following interfaces should be run on. It should be run. Okay, so let me do this first. Let me go back up to the topology. so you guys can still see the topology. And let's go back down to the question over here. Okay, this is number 2 question. Got highlighted. And what I'm going to do for right now is just put the IP address at the bottom. The IP address is at the bottom so we can see those a little bit better. I think this is a little bit better layout. So it says the following interfaces should run OSPF in area 1. So that should be the Core R1 Fast Ethernet 01. So let's start out there. So let's do a little, let's bring this up so you guys can see the iPad one more time. Put that right there. Let's just do a line right here to separate the area 1. So let's do Core R1, starting there on the Fast Ethernet 01. So that is going to be right here, Fast Ethernet 01. We can see its IP address is 12.1.0.1. So we want to do 12.1.0.0, and it's going to be in 0.0.0.3 for area 1. Again, it has a 255.255.255.252. So you do 255 minus 252 to get the wildcard mask of 0.0.0.3. And we want to do it on D switch 1's Fast Ethernet 01 in each switch virtual interface, SVI, that is configured with an IP address. So let's start out on D switch 1's Fast Ethernet 01, and it has an IP address of 12.1.0.2. So let's do D switch 1. It's going to be a 12.1.0.0, and it's going to be a 0.0.0.3 for area 1. And we want to do each SVI, so we could really just do the whole subnet right here. So we want to do a 12.1.1.0, and we can do an O.O.O.255 to include the whole network for area 1. Perfect. All right, so that is the area 1 interfaces. Moving on, it says the following interfaces. Oh, let me read this first. It says your configuration should follow the same restrictions given in the previous step using the IP address table list, which network parameters should be used to satisfy this requirement. Okay, I wrote those out right here, so that's what we have. So perfect. Let's go ahead and move on to question 3. It says the following interfaces should be configured to run OSPF in area 2. So we have Core R2, Fast Ethernet 01. So if we go to Core R2, Fast Ethernet 01, we can see its IP address, which I just highlighted. So let's start out there for area 2. Let's put another line. Let's move the iPad up some, but not cover the IP address table. Let's do, what route are we on? Core R2, so Core R2. And we want to do the Fast Ethernet 01, just confirming, yes. So we do 12.2.0.0, and we do a O.O.O.3, and we do an area 2 for that one. And we want to do D switch 2 Fast Ethernet 01. So let's go to D switch 2 Fast Ethernet 01. That's its IP address. So let's do D switch 2. It has an IP address of 12.2.0.0, and it'll be a 0.0.0.3 for area 2. And we want to do all of its SVIs. So we can do that all with one command. We can do 12.2.1.0 because that starts out all of them, and then we'll do a 0.0.0.255 for area 2, and that'll include all of these IP address ranges. So that is perfect. We can do all of that in one command. So let's go ahead and move on to question 4. We're going to go ahead and configure Area 3, it says the following interfaces should be configured to run OSPF in Area 3. So we have Core R3. So let's go ahead and scroll down to Core R3. Let's scroll up. It's Fast Ethernet 10. Let me repeat that. The Fast Ethernet 10. So that is right here. We can see its IP address. So let's put another line here. Let's go to, let's write Core R3. And this IP address we want to include is 12.3.0.0. And it'll be 0.0.0.3 for area 3. And let's move on to D switch 3. It wants us to do the Fast Ethernet 01. And here's its IP address. So let's go ahead and write that down. D switch 3. It's going to have an IP address of 12.3.0.0. It'll be a 0.0.0.3 for area 3. And let's do all of its SVIs with one command. It's 12.3.1.0, 0.0.0.255, area 3. And that will include all of those SVIs. And last but not least, we're going to have to configure area 4. And we know router 4 and D switch 4 are going to be the devices that we need to configure. We can see that right here. Core R4 is Fast Ethernet 01. So let's start there. So we can see the Core R4 router, Fast Ethernet 01 IP address. So let's go ahead and do that one. Let's do Core R4. So we want to do 12.4.0.0.0.0.3 for area 4. And we want to do D switch 4 as well. Let's scroll down. D switch 4. It's Fast Ethernet 01 and all of its SVIs. So let's do Fast Ethernet 01 first. It'll be 12.4.0.0. It'll be a 0.0.0.3 for area 4. Okay. And let's move on to its SVIs. We can do all of those with one command, 12.4.1.0. And it'll be a 0.0.0.255 for area 4. All right, I think that's it. So it says list all of the network commands necessary to accomplish the configurations required in steps 1 through 5. Your configuration should be minimized where possible. So we did all of that right here. We showed all of our work. So for question 7, it says on each device running OSPF, is it necessary to use the same OSPF process identification? And no, it's not. You can use different process identifications, and OSPF neighborships and adjacencies will still work. So no for question 7. Question 8, it says D switch 1, D switch 2, and D switch 3 and D switch 4 are all layer 3 distribution switches. What command is necessary to configure IP routing on layer 3 switches? I think you have to put the IP routing command. Let me make sure I can go to the D switch here. We do an enable, we can do a configure terminal, and we can do an IP routing. And yeah, that will take us into, that will change us to be a layer 3 switch. If it's capable, that command will be available within Cisco iOS. So that's that on that. Let's move on to question 9. Question 9. It says, what command display? Well, we can check our answers as we go too. So let's go to the answers for question 7. So question 7 was the process ID. So it says it is not necessary to use the same OSPF process identification for each device running OSPF. And for number 8, it said what command is necessary to configure IP routing for layer 3 switch. We can see right here it says IP routing, so we got that right. let's not look at the answer for number 10 yet until we answer it. So it says 10. It says Cisco iOS mechanisms that can be used to specify the interfaces on each OSPF should run in which OSPF area these interfaces belong. Okay, so it says Cisco iOS has two mechanisms that can be used to specify the interfaces on which OSPF should run in which OSPF area these interfaces belong. Besides the network command, what other mechanism does Cisco iOS supply? So you can do it from the interface as well. You can go into interface configuration mode and configure the interface to participate in OSPF. You would just have to include the area. So let's see what it says about that. Yep, so you can do the IP OSPF area command, which needs to be used for specifying the interface. So like I said, you have to go in the interface configuration mode first, and then you configure IP OSPF area, and then you're able to configure OSPF without using the network statement. So right here it says, what is one of the major advantages of using the OSPF network command over the IP OSPF area command? If you use the network command, you can include many different, you basically can include a whole network. With each IP OSPF area command, it can be tedious if you have a bunch of networks and a bunch of different subnets. So that's one advantage. So right here it says, one major advantage of using the network mechanism over the IP OSPF area mechanism is that you can match multiple interfaces with a single command, resulting in reduced configuration steps. So yeah. All right, for 12, it says, in networks lacking a clear or simple IP addressing scheme, which configuration mechanism is more appropriate and why? Well, if you can't figure out the IP addressing scheme, it'll be best to use the IP OSPF area command so you don't butcher any network mask, because when you do the network command, you have to give a wildcard mask. So if you don't know the IP address scheme, it'll just be best to use the IP OSPF area command within interface configuration mode. And we can see that right here. It says, in networks lacking a simple or clear IP addressing scheme, the IP OSPF area configuration mechanism is more appropriate. Okay? So for 13, it says, list the IP OSPF area commands necessary to accomplish the configurations required in 1 through 5. We have all of those right here, so we're not going to list those. It says for 14, it says, what is the purpose of configuring a router ID for an OSPF process? It gives it a consistent IP address. So, OSPF, when it does its adjacencies and forms its neighborships, it needs to have a stable IP address. That IP address should not change. So that's the reason why you would want to configure a router ID. Let's see what it says. It says the purpose of configuring a router ID for an OSPF process is to guarantee a stable router ID for the device. Even if a router were to restart without a router ID configured, OSPF chooses the highest IP address of all loopback interfaces to be the router ID. If no loopback interfaces exist, OSPF would choose the highest IP address of all physical interfaces that are in the up line in protocol states. So like I said, you just want to make sure that you have a stable IP address. So like I said, if you don't configure a router ID, it says that it will use a loopback interface, because usually a loopback interface will not change. And if a loopback interface is not up on the device, it will use the highest IP address for a physical interface. So it says, what command configures a router ID within OSPF configuration mode? If you put router ID, that's where you configure the router ID. So let's go ahead and, yep, it says the router ID command configures a router ID. So that's perfect. Let's go to 16. It says, what command displays whether OSPF is running on each required interface? You can do a show IP OSPF interface. So you can see that right there. For 17, it says, in this lab, each distribution switch is configured to run OSPF on each switch's SVI. However, OSPF needs not to form adjacency on SVIs. What command should you issue to eliminate unnecessary OSPF traffic on these SVIs? So you should configure, what is it called? Where you disable hellos you disable hellos, so you make it a passive interface. Yes, that's what it is. And it basically stops sending that OSPF hello message to the SVI. So it says, what debug command verifies that unnecessary OSPF traffic is eliminated on SVIs? Well, you can do a debug. You can do a debug OSPF hello. So yeah, debug IP OSPF hello, and that command verifies that unnecessary OSPF traffic is eliminated on SVIs. So it says, what command displays the link state database? You can do a show IP OSPF database. You see the OSPF database, so you can see that right here. And lastly, it says 20. It says, what command displays whether the link state information that was learned was correctly added to the IP routing table? Well, anytime you're dealing with the IP routing table, you're just going to put a show IP route, and it should show you what's going on with the routing table. And we can see that is correct right here at the top left. So it looks like now we're about to start our configuration. So let's go ahead and bring the topology back up to the top left. That's good right there. Let's bring our instructions back right here. And let's go ahead and get into our configurations down here at the bottom. So it says, for task 2, it says verify and configure multi-area OSPF. So it says this task involves implementing and verifying configurations planned in task 1. So the first step, it says configure each router with a router ID following the pattern 1.A.B.1, where A equals the IP OSPF area number and B equals 1 for routers and 0 for switches, using OSPF process ID of 1. Okay, so let's start out with BBR1, and we want to configure each router with the router ID. So let's do, let me move my book. Let me just keep my iPad right there so we can see that. Perfect. Let's do a configure terminal. To go into global config mode. Let's do an OSPF. Let's do a router OSPF. Sorry, router OSPF 1 for process ID of 1. And let's go ahead and figure the router ID to be 1 dot. This is A is equal to the OSPF area number. So BBR1 is in area 0. So 1.0 dot B is equal to 1 for a router and 0 for a switch. So we're dealing with the router. So 1.0.1.1. So that would be the router ID for BBR1. Let's go to Core R1. Core R1 is in area 1, but it is also in area 0, but we already used the area 0 for BBR1. So let's do an enable for privilege exec mode. Let's do a configure terminal for global config mode. Let's do a router OSPF process ID 1 like it says. Let's do a router ID of 1.1.1.1. Okay, because 1 dot, and it's in area 1. It's a router, so for B it's 1, and then that 1. Yeah, so that's perfect. Let's make sure that is correct, and it is. For Core R2, let's do an enable for privilege exec. Let's do a configure terminal. Let's do a router OSPF 1. Let's do a router ID of 1.2.1.1. Perfect. Let's go on the router Core 3. Let's do an enable. Configure terminals. Trying to just speed it up a little bit because this is the same repetitive step. Router OSPF 1. A router ID of 1.3.1.1. Perfect. Lastly, for the last router, let's do Core R4. Let's do an enable. Let's do a configure terminal. Let's do a router OSPF 1. Let's do a router ID of 1.4.1.1. Perfect. All right, and let's do the switches now. So we can start on D switch 1. Let's pull up D switch 2, D switch 3, and D switch 4. Okay. So we're going to start on D switch 1. Let's do a configure terminal. Well, we're already in global config mode because I did the IP routing command over here for the earlier question. So that's perfect. We're all good. Let's do an IP routing because we need to enable IP routing. And let's do a router OSPF1. Let's do a router ID of 1.0.0.1. Okay, it's perfect. Let's go to dswitch 2. Let's do an enable. Let's do a configure terminal. Let's do a router. Let me do an IP routing first so we can get OSPF configuration on this switch. And let's do a OSPF, or let me do a router OSPF, sorry, router OSPF1. And let's do a router ID of 1.1.0.1. All right, let's move on to dswitch 3. Okay, let me make sure I did that right. Okay, so this is area 0. So what area? So no, this is incorrect because it's area 1. So this should be what A is the right. So I did this wrong. Let me do a no router ID of 1.1.0.1. I'm glad I caught that. And let me do a no router ID of 1.0.0.1. Okay, we want to do a router ID of 1.1.0.1 here. Router ID of 1.1.0.1. Okay, that's good. Let's do a router ID of 1.2.0.1. There we go. Let me do an enable configure terminal. Let me do a IP routing to get the OSPF configured on here. Let me do a router OSPF1. And let's do a router ID of 1.3.0.1. Let's go to dswitch 4. Let's do an enable. Let's do a configure terminal. Let's do an IP routing. Let's do a router ID. Let me do let's do a router OSPF1. Let's do a router ID of 1.4.0.1. Alrighty. So it says verify your configuration. Let's verify. Let's do a do show IP OSPF. We can see our router ID of 1.1.1.1 for core R1. We can do the same thing on all of these devices. Do show IP OSPF. Oh, I put do show IP OSPF. I omitted the IP. So we see the correct address here. Do show IP OSPF. We see the correct ID here. Do show IP OSPF. The correct here. Just verifying all of them. Do show IP OSPF. Yep, everything looks good on dswitch 1. Do show IP OSPF. Everything looks good here on dswitch 2. Do show IP OSPF. Looks good here on dswitch 3. And lastly, dswitch 4. Do show IP OSPF. And everything looks good here on dswitch 4. So that's perfect. All right, it says verify each router in area 0. Oh, not verify. It says configure each router in area 0 to run OSPF on the required interfaces by using the best possible configuration mechanism. So on BBR1, it says using the best configuration mechanism. So since all of these are serial 00 interfaces, it may be best to just go ahead and configure them. Let me see what it's going to say if I do help here. So it says, okay. Okay, that makes sense. Okay. So for each one, for area 0, it wants me to use the network command for all of these networks. It wants me to use the network command. And then for each of the serial 00 interfaces, it wants me to it wants me for R1, R2, R3, and R4 to use the interface command. So not the network command, but the interface command. So I did get some help on this one, but I wanted to see how Boson wanted me to input these commands within the routers themselves, because if I do the network command instead of the IP, if I do the network command instead of the interface command, Boson will grade me wrong for it. So I just want to make sure I do the right command, whether it's the network or the interface command, so I get the lab correct at the end. In the real world, it wouldn't matter, but I have to submit my actual running config through Boson NetSim. So if something is off, it will basically grade me wrong, no matter if I use the network command or the interface command, even if the configuration is right. So I hope that makes sense. But let's start out on BBR1. I did break down all of the subnets in writing, so I do know how to subnet out the network and break down the wildcard mask and things of that nature. Like I said, I just want to make sure that my running config within each device is right within Boson when it's time for me to get graded. So let's go ahead and get into the actual config. So it wants me to do a network of 12.0.0.0, 0.0.0.15 for area 0 for the first command. And then for BB, not for BB, for core R1, it wants me to do an interface serial 00, and it wants me to do an IP OSPF 1 for process ID 1, area 0. All right. Do the same thing over here on core R2. Let's do an interface serial 00. Let's do an IP OSPF process ID number 1 for area 0. Do the same thing for core R3. Let's do an interface serial 00. Let's do an IP OSPF process ID 1 area 0. Same thing for core R4. Let's do an interface serial 00. Let's do an IP OSPF 1 area 0. Perfect. All right. So it says verify that each required interface is running in OSPF 0. So let's start out on BBR1, and we can see a couple of adjacencies coming up with our other routers. So that is perfect. That is what we want to see. You can see it's going from the loading to the full state, and we do want to see all of our neighbors in the full state. That means that they're sharing the same LSDB, which is perfect. So let's do a do show IP OSPF interface. And here's our output, so we can see that the serial 00.101 is in area 0 right here, so that's perfect. We can see that the serial 00201 is also in area 0. That's what we want. And we see the serial 00301 is also in area 0. Perfect. And the same thing for the 401 is also in area 0. So those are all of the sub interfaces that we wanted. Let's go to core R1. Let's do a do show IP OSPF interface. We can see the serial 00 interface is up and in area 0, which is what we configured up here. So that's perfect. Do the same thing on core R1, core R2, I'm sorry. Let's do a do show IP do show IP OSPF interface. We can see that this serial 00 is up and in area 0. Perfect. Let's verify on R3. Let's do a do show IP OSPF interface. We can see that this serial 00 is up and in area 0. And lastly on R4, let's do a do show IP OSPF interface. And we can see that its serial 00 is up and in area 0 as well. So that's all of those configured. So it says configure each core router in area 1 to run OSPF on the required interfaces by using the best possible configuration mechanism. So we're going to go to area. We want to configure for area 1. So that would be core R1 and D switch 1. So let's go to core R1 and we want to configure, let's see what it wants in Boson for me to do here. So on core R1, it just wants me to do the fast Ethernet. It wants me to do it in interface configuration mode. So we could do the network like I put right here in my notes, but it wants me in Boson to do it on the actual interface itself. So if I go into interface, let me do a do show CDP neighbor here. Okay, I got the fast Ethernet 10, which I want to do. So let's go into interface, fast Ethernet 10. I want to do an IP OSPF for process ID 1 for area 1. Okay, and let's go over, it says right here for the next step, what is the next? It says configure each distribution switch in area 1 to run OSPF on the required interfaces by using the best possible configuration mechanism. So I'm guessing it's going to have me do the network command on this one. Okay, so no, it's not. It's asking me to do the fast Ethernet 01 as, so that will be the, okay. So I use the network command for the SVIs. So it wants me to use the network command for the SVIs, but not for the fast Ethernet 01 connection. So if I do a do show IP, if I do a do show CDP neighbor, okay. So let's go into interface fast Ethernet 01. Let's do an IP OSPF for process ID of 1, area 1. And let's do a router OSPF 1 to go back into OSPF configuration mode. Let's do a network command of 12. I have it right here, 12.1, 12.1.1.0.0. And we want to do a 0.0.0.2, 0.0.0.255 for area 1. All right, that's what we want. All right, so it says configure OSPF on the required interfaces to enable OSPF for area 2. Oh, we can see our adjacency just came up with 1.1.1.1. So that is, that should be, I think that's core R1. Yeah, that's core R1's router ID. So D switch 1 has a full adjacency now with core R1, which is what we want to see. So let's go ahead and move on to area 2. Let's go ahead and move on to router R2. I'm going to do the same configuration over here. So let's do a do show CDP neighbor. All right, we want to do the interface fast Ethernet 1/0. We want to do an IP OSPF process ID of 1 for area 2. Okay, and let's go to D switch 2. Let's do a do show CDP neighbor here. Okay, so for the interface, fast Ethernet 01, we want to do an IP OSPF process ID 1 of area 2. And we want to do an interface we want to do a router OSPF process ID of 1. Let's do a network command for, it's right here, I got it down here. It'll be a 12.2.1.0 0.0.0.255 for area 2. All right, so that's on D switch 2. All right, it says verify your configuration. So let's go to core switch. Oh, not core switch. Let's go to core R2. Let's do a do show IP OSPF. Oh, we just seen our adjacency come up with D switch 2. Let's do a do show IP OSPF interface. We were looking at area 2 right now. So we can see that our fast Ethernet 01 is up in area 2. And let's verify that we're good on D switch 2. Let's do a do show IP OSPF interface. And we can see that all of our SVIs are up in area 2, which is perfect. And we can also see that this fast Ethernet 01 is up in area 2 as well. So that's good. So verify your, it says configure OSPF on the required interfaces to enable OSPF for area 3. So let's go to core R3. Let's do a let's do a do show CDP neighbor first. Let's get that. All right. So we want to go into interface fast Ethernet 10. We want to do an IP OSPF 1 for area 3. All right. Let's go to D switch 3. Let's do a do show IP OSPF or do show CDP neighbor. Let's go into the interface for fast Ethernet 01. Let's do an IP OSPF 1 for area 3. So we're going to do this fast Ethernet configuration for interface configuration mode. And then we're going to go into router OSPF for process ID of 1. We're going to do a network command that we put right here, which is 12.3.1.0 0.0.0.255 for area 3. All right, and for question 11, it says verify your configuration. So let's go to core R3. Let's do a do show IP OSPF interface. We should see that adjacency come up with D switch 3 here in a second. Probably about to come up here any second now within our CLI. Just waiting for that to come through before I press enter on this command. Give it a few seconds. Give it a few more seconds. Let's see. Yep, we just seen our adjacency come to full to loading with D switch 3. We can see that our fast Ethernet 01 is up and then area 3 right here. Perfect. Let's go to D switch 3. We can see that it's loading to full as well. So we want to see for our adjacency. Let's do a do show IP OSPF interface. And we can see our fast Ethernet 03 is up in area 3. And then we should see all of our SVIs. And we do. So that is perfect. They're all in area 3 as well. So lastly, it says configure OSPF on the required interfaces to enable OSPF for area 4. So let's go on core R4. Let's do do show CDP neighbor so I can see my interfaces, what they're connected to. Okay, So we want to do interface fast Ethernet 01 or 10, I'm sorry, 10. Let's do an IP OSPF process ID 1 for area 4. And let's go over to D switch 4. Let's do an do show CDP neighbor. All right. So first we want to do the interface fast Ethernet 01. We want to do an IP OSPF 1 for area 4. And then we want to do a router OSPF 1. And we want to do a network command. Our last network command, which we have right here, is 12.4.1.0.0.0.255 for area 4. And that should be done. It says verify your configuration. So let's go to Core R4. Let's do a do show IP OSPF interface. Let's do the same thing on D switch 4. And we should be seeing our JCC come up here in the next few seconds. Let's do a do show IP OSPF interface. Go over to D switch 4. We can see that our fast Ethernet 01 is now in the upstate, and it's in area 4, and we just seen our adjacency come up with D switch 4, which is perfect. We do the same thing over here. Let's do a do show IP OSPF interface. And we can see all of the SVIs in our fast Ethernet 01 is up and in area 4 right there. So that's perfect. So question number 14, it says, in this lab, no devices running OSPF exist on the SVI broadcast segments on D switch 1. Observe hello traffic. Does unnecessary OSPF traffic exist on this switch? Disable debugging after you have reviewed the output. So let's go to D switch 1. D switch 1. Let's go to end. And let's do a debug IP OSPF hello. So let's see if we are sending hellos out of, yep. So we can see that we're sending these hellos out of these SVI interfaces, but they're connected to devices that will never receive any hellos. They're connected to layer 2 switches, the access layer switches. So they're not routing capable. So there's no need to send these hello messages out of these SVI interfaces. So let's do a no debug IP OSPF hello. Okay, so just turn the debugs off. So it says on each distribution switch, eliminate unnecessary OSPF traffic. So on D switch 1, let's go into global config mode. Let's do a router OSPF 1. We can go into well, we didn't even have to go into that. Let's do a do show CDP neighbor. So we want to go into the fast Ethernet 02 because that connects to our access layers, the access layer switch, and we want to do configure it as a passive interface. So let's do IP OSPF. Well, no. Maybe I do need to go into router OSPF 1. Forgot how to configure the passive interface. Okay, so passive interface right here for the fast Ethernet. That was fast Ethernet 02. All right. Now let's go to D switch 2 and do the same thing. Let's do a do show CDP neighbor to see which port connects out to that access layer switch. Same thing, fast Ethernet 02. Let's do a router. Oh, it looks like we're already in. Let me make sure that we're in router OSPF configuration mode. And let's do a passive interface for fast Ethernet 02. Do the same thing for D switch 3. Let's do a do show CDP neighbor. Let's do a passive interface for fast Ethernet 02. And let's lastly do it for D switch 4. Let's do a do show CDP neighbor. It's probably going to be that fast Ethernet 02 port still, but just wanted to make sure. And it is. So let's do a passive interface for fast Ethernet 02. All right. So it says on each distribution switch, verify that traffic has been eliminated. Okay, so let's go to D switch 1. Let's do an end. And let's do a debug for IP OSPF hellos. See if we're still sending. Okay, so we are. So maybe I did that wrong. I think I did do that wrong. So I need to go into each interface for the VLAN. So I did do that wrong. So, okay. So let's do a no debug IP OSPF hello. Okay, let's go back into global config mode. Let's go into router OSPF 1. Let's fix this. We want to do a passive interface for VLAN 0011. A passive interface. Yep, this is it. Passive interface for VLAN 0012. A passive interface for VLAN 0013. Oops. 0013. And a passive interface for VLAN 0014. All right. Let's do the same thing over here on D switch 2. Let's do a passive interface. Well, let me do a do show VLAN brief. See all the VLANs. Okay. Let's do a passive interface for VLAN 0021. Let's hit the up arrow for 22, up arrow for 23, up arrow for 24. Let's do the same thing on this. Do show VLAN brief on D switch 3. Let's do a passive interface for VLAN 0031. Up arrow 23, up arrow 33, up arrow 34. And lastly, let's do a do show VLAN brief. Let's do a passive interface for VLAN 0041, up arrow 42, 43, 44. Now let's verify on D switch 1. Let's do an end. Let's do a show. Well, let's not do a show. Let's do a debug IP OSPF hello. Let's try this again. All right, so we're sending out for fast Ethernet 01, but it says end of hello processing. So we're not sending out to those SVIs, which is what we wanted. So that's perfect. So let's do a no debug IP OSPF hello. All right, it says on BBR1, verify link state information was correctly added to the IP routing table. So let's do a do show IP route. And we can see all of these routes shared within OSPF with the O right there and the administrative distance of 110. So that is perfect. And it says on BBR1, verify connectivity with each workstation in the lab. Refer to the IP address table. So let's ping every workstation. So let's go up here to the IP address table. And let's just ping every single workstation. So let's start out with PC1 and we're going to work our way down to PC12. So let's do a let's do a ping 12.1.1.66. It's a success. Let's do a ping to 12.1.1.130. That's a success. Let's do a ping to 12.1.1.194. Just verify connectivity throughout our network. We're able to ping that PC. Let's ping 12.2.1.66. Oops, typed that wrong. 12.2.1.66. Okay, that's good. Dot 130. That's good. Dot 194. 194. That's good. Okay. Let's do a ping to 12.3.1.66. That's good. Dot 130. That's good. Dot 194. 194. Perfect. And let's do a 4.1.66. Good. Dot 130. That's good. And 194. Perfect. So let's grade. Hopefully we did everything correct. And we did. So this was an hour-long lab, but we definitely learned a lot within OSPF. The OSPF labs are usually longer, but they do include a lot of knowledge that is needed. So thank you guys for watching this one. I'll see you in the next one.